There are very few research studies, very, very few, that I have read and immediately thought the results were so powerful they needed to be blasted from the rooftops and everybody should know about them. But here's one. Two British professors, Eddie Gray and David Tall, worked with 72 students between the ages of 7 and 13, and they had asked teachers to nominate students they thought of as above average, average, and below average. They then gave the students various addition and subtraction problems to do, and they categorized their strategies. For example, they gave them problems such as 7 plus 18, which is the addition of a single-digit number to a teen-digit number, as you can see here. And what they found was that students used 4 different strategies when they worked on number problems. So the strategies were, some students counted all. So with 7 plus 18, they would say 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, and count up to 18. And then to add them, they would count them all again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and go on like that. The slightly more sophisticated strategy of counting on is when students would add up to 7 or to 18 and then continue on. So if they'd added 18, they would then say 19, 20, 21. Known facts was when students just knew what the number bonds, they just remembered them. And what they called derived facts, which I would call number sense, and which this whole session is about, was when students were able to break numbers apart and decompose and add them and use them flexibly. So for example, they might say with 8 plus 17, I'm going to take 8 plus 2 and make that into 10. Or they may break 17 into 15 plus 2 and then calculate 15 and 2 and 8. So they make the problems into easier addition problems. And the results from the 8-year-olds was stunning to me. So the above average students, 30% of them knew the numbers, they used facts, known facts. 61% of them used number sense, so they used the numbers flexibly. And 9% of them counted on. In the below average group, 6% of them used known facts, none of them used number sense. 72% of them counted on, and 22% counted all. And when they worked with the 10-year-olds, they found that the below average group were using the same number of known facts as the above average 8-year-olds, so they're sort of caught up on the number they remember over time. But still virtually no number sense, and instead they were continuing to count. So why is this finding so important? The researchers who did this study put it well. They concluded that the low achievers, so often thought of as slow learners, were actually not working more slowly, but they were learning a different form of mathematics. And what's more, the mathematics that the low achievers were learning was the more difficult form of mathematics. And low achievers also are often identified as low achieving in school, and the help that they then often get is more procedures, more emphasis on doing procedures very carefully, rather than being taught to use numbers flexibly, and that's probably the very, very last thing that they need. And low achievers also are often identified as low achieving in school, and the help that they then often get is more procedures, more emphasis on doing procedures very carefully, rather than being taught to use numbers flexibly, and that's probably the very, very last thing that they need.